With funding from a National Science Foundation grant, a research team from the University of North Texas Department of Geography is studying how trees in Denton could be acting as urban air filters and to what extent. We spoke with Dr. Alexandra Paunette Gonzalez to learn more.
Fossil fuel emissions and biomass combustion, things like fire and cook stoves, emit particles into the atmosphere, and those particles are called black carbon particles. Many people know black carbon by the name of soot. So in urban areas, the primary source of soot to the atmosphere are diesel engines. So whether it's school buses or trucks or heavy duty vehicles and so forth. And so when that stuff is emitted, it goes up into the atmosphere and it doesn't just go away, it settles back down to the surface. And so one place that those particles can settle is on the canopies of trees. How can trees serve as urban air filters? They capture the particles, the water falls through the tree, those particles are delivered to the soil. But another thing that can happen is that the soot particles, if you look at a leaf, and a lot of these leaves are dead already, but they tend to have like a waxy cuticle layer. And in that waxy cuticle, in that surface, the soot particles can actually become embedded in the wax. And so when it rains, that soot particle won't be removed with water, but it will stay in the leaf. So when the leaves drop from the trees, like they are now in fall, whatever's in that wax is also going to be delivered to the soil.
Black carbon is an extremely small particle. When humans inhale these particles, it can cause cardiovascular disease and respiratory illness. This makes black carbon emissions an air quality and human health issue.
We have 57 samplers across the city of Denton. Some of them are rainfall samplers, so they're out in the open. And then about 41 of them are underneath the oak trees. And so what we do is we set out our equipment, and then 24 hours before it rains, then it rains, and then within 24 hours we pick up our samples, and then we process them in the lab, and we can measure the amount of soot in that water. The other thing that we're doing on a monthly basis is picking the leaves off the trees, and then in the lab we can take that soot out of the leaf wax and measure how much is in the leaf wax. And then the last thing that we're doing is we're measuring how many leaves fall to the ground over time. And so if we know how many leaves are falling to the ground underneath the tree, and we know how much is in the leaf itself, we can do a simple multiplication and calculate how much soot is landing on the soil with litter. Basically, we built a very simple structure. This is just a metal bar with a piece of PVC and a cap on the bottom to keep it secured. And every time that it rains, we come out and we set up. We put a funnel out and we put a bottle out. So right now I'm just gonna put this here and you'll see the bottle. Every sample collector has a number. All right, so we have the number on the cap. Close that. And then we have, so here's the actual sample. So this is the rain that fell last night. I think it's about an inch worth of rain, maybe a little bit less. And then we just cap this, right? So as you can see, this is simply just the structure that holds the bottle, and it holds a glass funnel.
After the collections were completed, we headed to the Ecosystem Geography Lab, where the research team analyzes the water samples as well as leaf litter collections. Jenna Rindy showed us how the carbon is extracted from the leaves.
Today I am extracting leaves with chloroform. So yesterday I extracted them in water, and before that I physically removed leaves from 20 different trees across Denton. I washed them with water to get any of the particles off that would be on the top sides of the leaves. And now I am using chloroform to remove the waxes of the leaves. And then I filter that over a filter, and then we analyze that filter, and it can tell us how much black carbon is on those filters, which is a component of particulate matter. So it's formed mostly from diesel fuel exhaust. So trees that are closer to roads tend to have higher concentrations of black carbon in them. So we're just trying to determine what that content actually is.
Black carbon is the second most important component of the atmosphere that is causing climate change. So we want to get it out of the atmosphere to keep places cooler and to keep people healthier. Now, one last thing that I want to close with that's really important is that soot. We believe that soil is an important place where that soot can be retained. So we think that it's a place where that soot can eventually be stored in some cases for hundreds to thousands of years.
The study is scheduled to wrap up this November. However, with further funding, the research group would like to continue sampling through next March.